We okay? All right, looks like we're getting some good responses. And like I said, I will save this as a PDF, so don't worry about trying to copy everything right now. Just pay attention, because this will get saved and uploaded to Blackboard immediately. Okay, so let's look at this next one, E part. Notice that this is a little bit more complex because now we have a fraction and an inequality all together. You cannot cross multiply because this is not an equation. So our only option is to get everything on one side and try to figure out if this is greater than or equal to 0. So since that's a positive 3 on that other side, I'm going to subtract it over. I go ahead and write it over 1 because I know that my next step is going to be to get a common denominator here. My common denominator would have to be 2x plus 3 since that's the only denominator I have really. So I'm going to multiply top and bottom of this fraction by 2x plus 3. So what that's going to give me is 4x minus 1 over 2x plus 3. This would be minus 3 parentheses 2x plus 3 over 2x plus 3. I just wanted to write it a little bit neater. Now, the reason I wanted to write this a little bit neater is because when we go to combine this now, you have to make sure that you distribute this negative sign to everything in that fraction right there on the top. So it goes with that 3 when we distribute. So this would be 4x minus 1 minus 6x. Negative 3 times positive 3 would be negative 9 all over 2x plus 3 greater than or equal to 0. Your next step would be to try to clean up that numerator. So if I combine like terms, I get a negative 2x because that's 4 minus 6. Negative 1 minus 9 would be negative 10. And now I have the most clean or combined numerator that I can get right now. Now, yeah, there's questions about whether or not you could pull out that negative 2. It's actually detrimental to pull that out because it's going to mess up your chart method, which is what we're going to do next. So essentially the rules are, if you don't just have a linear inequality like the first one we did, in other words, it was just x to the first power, if you have 2 factors or a quadratic or a cubic, or if you have a fraction with x's and an inequality, all of those need to be done using our chart method we learned in section 2.7. So we have what are called critical values. Critical values are places where either the top or the bottom could equal 0. To find those numbers, you set both parts equal to 0 and solve. So negative 2x minus 10 equals 0. We would add over 10 and divide by negative 2. So it looks like my top value of concern is negative 5. For the bottom, I would set 2x plus 3 equal to 0. Subtract over 3, divide by 2. So the bottom number has a negative 3/2 as the number of critical value for our what we're looking at. So then remember the next step was once you had your critical values, you made a chart so that you could evaluate your signs on each side of the critical values. We placed them in order from least to greatest, so the smaller one would be negative 5, and negative 3 over 2 is like negative 1.5, so that would go next. Before I do anything else, we need to talk about, are these open or closed points? When you look at the top always obeys whatever this symbol is. So because that has an equal to, the top is going to be closed. That means I can think about drawing a closed circle on negative 5. A denominator can never be closed because remember, denominators can't equal 0 or you're undefined. So anything in a denominator is always going to be open. So notice we have a closed one and an open one based on this is following the rule because it's on top. The bottom can never be closed, so it has to be open. Once you get that set up, the next step, just to keep you from having to do this at the end, would be to write your intervals down. So I'm going to write those down right here. And notice I'm using brackets and parentheses when appropriate based on the opened or closed circles. So the next thing you do after you've got this is you pick test values. Your test values have to be numbers in this interval or they don't make any sense. So this has to be something less than -5. I always go pretty close and just pick the next number down, so -6. Remember, this is about -1.5, so something between -5 and -1.5, I could use -2. This is -1.5 again, because I can use my calculator to figure that out. So something bigger than -1.5, something easy, would be 0. Once you have all of your test values picked, you write your factors down. So -2x minus 10, 2x plus 3, and then your final step is, after we worry about what these signs are going to be, we want it to be greater than or equal to 0, which means we want positive answers at the end because it's bigger than 0. So here comes the part that's just really just evaluating. You plug this number into each part and you ask the question, is the answer positive or negative? So be careful with this first one. -2 times -6 would be positive 12. 12 minus 10 would be positive 2. 2 times -6 would be -12, plus 3 would be -9, so that's a negative. Then you ask, since this is division, what's a positive divided by a negative? Well, that would just be a negative. -2 times -2, because we're plugging in this one now, is positive 4. Positive 4 minus 10 is -6. -2 times 2 is -4, plus 3 would be -1. Notice we get two negatives, which multiplies to make a positive, or divides to make a positive. Multiplication and division follow the same rules for signs, so it doesn't really matter which way you say it. 0 is easy to plug in because the x's go away, so you're just left with these two numbers. So that's a -10 and a positive 3. So again, when I multiply or divide those, I get a negative sign. Once you've completed your chart, you ask the question again, what was I looking for? I was looking for positives. So the only positive in my chart overall is this final column right here. If you've done your interval at the top, your answer is just right above you. So the answer is -5 to -3/2, with this one being a bracket because it came from the top, and this one being a parentheses because it came from the bottom. Okay, I know that one was a really long problem, so I'm going to give you a second to assimilate what we just did, and then let me know if you guys are good or if we have more questions on that one. So remember, just a quick okay or good in the chat box is sufficient. Okay, let's move on to our next one that you guys had a question about, which was still from number 1. And that was 1H. I'm giving myself plenty of room. And periodically I'm going to save this file so that when we're done I can easily capture all of the writing. So it'll just take it a second before I can write again. Okay, so this one's kind of a similar setup, except instead of having a number on this side, you have another fraction. So what you're going to do is you're going to take x plus 2 over x plus 3, and then we're going to move this second fraction over here so that we'll have a 0 on this side. Because this fraction has no sign out front, we assume that this is a positive fraction overall when we think about moving it. So when I move it over, I'm going to move it over by subtracting. So there's my first step. I'll then need to get a common denominator for both. So it looks like this guy's missing the x minus 2, and this one's missing the x plus 3 that the other denominator has. I would then take a second to rewrite this so that it's a little bit neater. So I have x plus 2 and x minus 2, and then subtraction sign, x minus 1 times x plus 3, all over x plus 3, x minus 2. And then that's less than or equal to 0. Be careful here thinking that you can cancel. You cannot cancel anything because there's a subtraction sign in the middle here. This requires you to FOIL and then subtract. Okay, so we need to FOIL these out. So this would be x times x, so that would be x squared minus 2x plus 2x, and negative 2 and 2 makes negative 4. I still have my minus sign because I haven't done anything with that yet. X times x would be x squared. X times 3 would be 3x. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. And that's still, don't lose your fraction, all over x plus 3, x minus 2, and still less than or equal to 0. My next step is to clean up that top. I could go ahead and distribute the negative if I want, or I could combine like terms. I do notice that those are going to cancel out because that's a positive 2x and a negative 2x. And then this would make 2x overall, positive, because it's a 3x minus a 1x. So then I just need to distribute this negative and then make sure I bring these down. So that would be x squared minus 4. Negative 1 times x squared would be negative x squared. Negative 1 times 2x would be negative 2x. And negative 1 out front times negative 3 would be positive 3. So we're almost finished with the simplification. So I'm going to move this up here to finish. Notice that your x squareds are going to cancel out because there's a positive and a negative one. So you just get negative 2x, if you're putting them in descending order, negative 4 plus 3 is negative 1. So this actually cleans up nice by the time we're done. And then this is what we have here. So we do still get some critical values. The top, we'll have to set this equal to 0 to figure out what that one is. So negative 2x minus 1 equals 0. Add the 1 over, divide by negative 2. So negative 1/2 is one of my critical values, and it will follow the rule of this. Remember, the top always follows that rule. So this will be closed. The bottom will be open no matter what, because bottom cannot equal 0. And we have 2 of them. And they're actually, I can solve those without doing the work. That would be a negative 3 and a positive 2. So notice I have 3 critical values altogether. So once we get our critical values, we make our chart to check for our signs. Don't forget to place these in order from least to greatest. So negative 3, then negative 1/2, and then positive 2. The bottom ones are open, so open circle, and the top one is closed. So that helps me set up my intervals with the correct symbols. Negative infinity to negative 3, negative 3 to negative 1/2 with a bracket, negative 1/2 to 2, bracket on the 1/2, parentheses on the 2, and 2 to infinity. Those are kind of hard to read. Okay, so then what we do is we pick our test values for each region. So something smaller than negative 3, I would do negative 4. Something between negative 3 and negative 1/2, negative 1 would be okay. Negative 1/2 to 2, since it went from negative to positive, we could use 0, and bigger than 2, we could use 3. So then notice we have our factors, negative 2x minus 1, and then on the bottom we had an x plus 3 and an x minus 2. And then our whole thing needed to be less than or equal to 0. So we're looking for negatives. So, okay, so we just have to really quickly plug these in and solve them out. Negative 2 times negative 4 would be positive 8, minus 1 would be positive 7. Negative 4 plus 3 would be negative 1. Negative 4 minus 2 would be negative 6. 2 negatives make a positive overall. Negative 1 times negative 2 would be positive 2. Minus 1 would be positive 1. Negative 1 plus 3 is positive 2. Negative 1 minus 2 is negative 3. 1 negative overall in the group makes a negative. 0 is just going to give you the signs of the numbers that are constants. So that'd be negative, positive, and negative. Two negatives make a positive. And then negative 2 times 3 would be negative 3 minus 1 more would be negative. 3 plus 3 is 6, so that's positive, and 3 minus 2 is 1, which is positive. One negative makes a negative. So because we wanted less than or equal to 0, we have to circle the regions that have negatives. So that means my answer for this one would be negative 3 to negative 1/2 with a bracket, union 2 with a parentheses to infinity. So all I did was look right above to grab those intervals. So that one again was a long one. The ones that have the fraction ones are always the longer of the inequalities. Any questions about that? Looks like some people are saying they're okay, they're good. No questions? Okay. All right, so that moves us into a different topic. We're still doing an inequality in this next one, but it is an absolute value inequality. So that does make it a little bit different of a problem. I'm going to go ahead and save real quick. This first one, when you're solving these absolute value equations or inequalities, either variation, the first thing you want to do is make sure that the absolute value is the only thing on that side by itself. In A part, we do have that. So anytime you're dealing with an absolute value less than a positive number, you always set it up the same way. You take whatever's inside that absolute value and you put it between the negative of the number you started with on this side and the positive of that number. So if it's a less than symbol and this is isolated and this is positive, that is always the way you set it up. So we're going to set this up as negative 6 is less than 3 minus 2x over 2 and is less than 6. Notice we just used this same symbol twice. To solve this, I would multiply everything by 2. And that would give me negative 12. In the middle, the 2's would just cancel, so that would be 3 minus 2x, and we get a positive 12. Again, we're trying to solve this. This is kind of like 1a that we did together, so we need to subtract the 3 from the middle and the other two sides. That gives me negative 15 is less than negative 2x is less than 9. And then finally, we divide everything by negative 2. Because we're dividing by a negative, not only does it change the sign of the fraction, it also flips the inequality. So now they're both greater thans. Since they want us to write our final answer in interval notation, you still need to write it from least to greatest. So since there's no equal to, there's no brackets. So this would be negative 9/2 to 15/2. Are we okay with that one? And like I said, you don't have to worry about copying all this because I am going to post it right after we're done in a PDF format for you guys. So the next one that we had a question about was also in this section, but it was C. This one is not isolated. Notice the absolute value has a 5 in front of it and a plus 10 at the end. So the first thing we want to do is move that stuff around. You do not distribute numbers into absolute values. That is not always legal, so we don't do it as a rule. So then I would divide both sides by 5. So I get absolute value of 2x minus 4 is less than or equal to negative 4/5. Now, if you have an absolute value, a less than sign, and the other side is negative, a positive always pops out when you do an absolute value. So a positive is never less than a negative. That just doesn't make sense. So this is the scenario where you don't need to solve anything, it's just no solution. Now if it had been a greater than symbol and a negative, it would have made sense because positives are always bigger than negatives. But because it's a less than, it's not true. Do we feel okay on part C? Okay, seeing quite a few goods, so we're going to go ahead and start moving down. The next question you guys asked for was number 4. Just because of our time restraints, because I'm looking, we've already spent 30 minutes, I'm going to do A part first, or B part. Actually, I'll do B part first, and I'm going to come back to 4A if we have time. I don't want to keep everybody all night if the problems are pretty similar. The main difference with how you attack A and B has to do with whether or not you're on the y-axis or the x-axis. So let's look at B really quick. This says find all the points on the x-axis. That means it's an x-intercept. X-intercepts are always the some number, we don't know what it is, but they're going to be some number, and then comma 0. The distance is 5, so that's our D, and then we have a second point, so this is another ordered pair. Our distance formula, the reason I'm using the distance formula is because they use the word distance, is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's Pythagorean theorem essentially. So if we take x and 0 and -2 and 3 as our ordered pairs and we use 5 for our distance, we can plug in everything that we know and hopefully solve for this missing x. So this would be 5 equals the square root. I normally like to start with the variable first just so this looks nice. So it'll be x minus -2 squared plus, in this, so since I started with x, I have to start with 0, 0 minus 3 squared. So this minus a negative here will turn into a plus. So that'd be x plus 2 squared. And this I can go ahead and work out. That'd be -3, and when I square it, it becomes +9. So that's where I'm at this point. I then usually want to solve for x, but I want to not have to square this out if I don't have to. So one thing we can do is we can try to get rid of this square root on the right side by squaring both sides. If you square both sides, on this side you actually get 25, but on this side the square root and square cancel and you're left with what's underneath. My next step would be to get that 9 to go over and join that 25. So this would be 16 equals x plus 2 squared. And then to finish solving this, we would take a square root of both sides. Anytime you physically draw in a square root yourself, the side that doesn't have the square on it needs a plus or minus. So this works out to be a nice number. That would be plus or minus 4. And then on this side, we just get x plus 2. To finish this, we would subtract the 2 over. And since there's no radicals, you can work these out. It's a -2 plus 4 and a -2 minus 4. So that would be a +2 and a -6. So that means I get 2 different x-intercepts. 2, 0, because remember x was the part we were solving for, and -6, 0. So both of those are exactly 5 away from this point distance-wise. And like I said, I'll come back to A if we have time, but I want to make sure we do at least one of every type that you guys asked for. So the only difference with this one is your generic point is 0y because it's a y-intercept. So you do the same process except this is the second ordered pair. Do we feel okay about that? So keywords to tell you that you're doing this type of problem is, notice you see something about the axis and you see the word distance. So that's how you know you're doing this application problem. Okay, I believe the next one we had a question about was 5C. So 5C says the line that is perpendicular to the line 8x plus 3y equals 1, and it passes through the point -9, 2. So the first thing we need to do is find the slope of this line right here. Once we find that, we will make it perpendicular, and then finally we will use our point. So find the slope of the line, make it perpendicular, then use your point. So the first step will be to find the slope of this line. So 8x plus 3y equals 1. The best way to find slope is to solve for y. So I'm going to subtract 8x over, and then divide everything by 3. So it looks like my old slope is -8/3. It's just whatever is in front of the x after we solve. To make that perpendicular, you flip it and you change the sign. So it becomes +3/8. Your final step is to use point slope, which is this formula, y minus y1 equals m parentheses x minus x1. This is when you finally use the point that we were given. So y minus 2 equals 3/8 x minus -9, which will actually end up being a +9. I usually distribute the 8 to the other side by multiplying both sides by 8. That will cancel out that little denominator there. So this would be 8y minus 16, and then I still have to distribute that 3. That would be 3x plus 27. I need to write my answer both ways, slope, intercept, and standard. I already wrote point slope when I just started. And they may, on some of these, they may have used a different point for point slope, like on B, they could have used either point. But let's go ahead and put this in slope intercept, and then we can all, well actually no, I'm going to do general first. General will be easier from this step. To put this in general, you need to move the 3x over to the other side and the 16. So that would be -3x plus 8y equals 43. Now normally I'm fine with this, and like I said, I'll accept this on the test if you want. If you don't like having a negative up front, you just change all the signs and it's still the same equation. So these both become negative and this becomes positive. So either one of those would work for me for general. If you want to go to slope intercept, you take either one of these, whichever way, so maybe I'll take the -3x plus 8y equals 43. And we resolve it back for y. So we add the 3x over, and then we divide everything by 8. So this would be y equals 3/8 x plus 43 over 8. Now on the test, we do not make you do both forms in one question. This was just so you could get lots of practice with converting. The question will be worded so that it'll either say write the answer in general or write the answer in slope intercept. We don't ever make you leave it in point slope. That's just trying to help you get started. So how do we feel about that one? Is that okay? All right, so that moves us down to number 6. Number 6 is sort of similar, but there is one defining feature that's different about it. It says not only do you want a perpendicular line, you also want something called a bisector. A bisector means you need a midpoint. Perpendicular means we need to know something about slope. So since all I have is two ordered pairs, I can use those to find the midpoint, and I can use them to find a perpendicular slope. So the first thing I'm going to do is the midpoint. Our midpoint formula was that you add your x's together, you cut them in half. You add your y's together, you cut them in half. So we just write this as 10 plus 8 cut in half. 22 plus negative 4 cut in half. That is 18 over 2 and 18 over 2. So this ends up being 9, 9. This will be used in a minute when we go to do our equation at the end, but there's the bisector. For the perpendicular part, you have to go back and find the slope of PQ. Remember, for slope, you have a formula where you subtract the y's on top and you subtract the x's on bottom. So it doesn't matter which way you start. I usually start with my second one first. So negative 4 minus 22 would be my top y's over 8 minus 10. If I start with negative 4 first, I have to start with 8 first in the bottom. You have to be consistent. So this would be negative 26 over negative 2, which reduces down to 13. The problem is that's the slope of PQ. We want a perpendicular slope. So our perpendicular slope will be 1 over 13, and since this is positive, ours needs to be negative. So that's how we get those first two parts. You need a bisector, which means you need a midpoint, and you need to know the slope of this so that you can make it perpendicular. Your final steps are to then write this as an equation. So y minus y1 equals m parentheses x minus x1. You have to use your bisector. You do not use these other 2 points for the actual equation. So this would be y minus 9 equals negative 1 over 13 x minus 9, because they're both 9s. I would multiply 13 to the other side just to clear out that fraction. Be careful here, you do still have to distribute a negative 1. So I need to distribute 13 to everything on the left side. So 13 times a 9 is 117. So this will be 13y minus 117. This is a negative 1 times both of those. So that'll be negative x and positive 9. The answer needs to be in general form. So that means get x and y on the same side. So if I add x over, I get x plus 13y, and then I also need to add over the 117. So that equals 126. So my numbers aren't small, but that's what it comes out to. So it's x plus 13y equals 126. Any questions on that one? Or do we feel good? Alrighty, let me save real quick and then we'll move on to the next one. Looks like our next question goes down to 9b. So we're moving towards the end now. And I'll need a little bit of space to be able to do this one. So I'm going to go ahead and write all of the things that I need to find. On none of these does it ask me to find domain. I just have to find the operations. And then I will finish off with f of g and then g of f. So f of g and then g of f. Okay, when you're adding two functions together, you just literally put the first function that they listed plus the second function. So we're doing part B. So this is it. Unless there's like terms, you can't do anything with this. So this is actually the answer for the addition. That's a radical, that's a polynomial. You can't add those two together. So that would be it for that one. For subtraction, you write the first one. And then just to be safe, you should write minus and then write the second function in a parentheses. Because when you subtract the whole thing. So notice that's going to change some signs. That would now be a negative 4x squared and a positive 18 when we distribute. Again, no like terms, so we can't multiply, or excuse me, we can't add them together or subtract them. For multiplication, you write the first function times the second one. So notice I'm just putting a parentheses. Again, this cannot be worked out. You're just writing what it looks like because you can't multiply things that are not in a radical with things that are. Now, if these had both been under radicals, we would be able to multiply them together, but since they're different, typically we write that with the polynomial up front for our final answer. Doesn't have to be that way, but just make sure it's in a parentheses no matter what, so that it says this whole thing is times this. For division, we just stack the first one over the second one since they said do F over G. So that would be that. There's nothing you can do to clean that up. You could pull out a 2 on the bottom, but it's not going to make anything cancel with anything on the top. Now here's where we get to the composition. For the first one, you're going to write F, and everywhere you see an X in that function, you're going to leave a blank because we're going to end up plugging G into F. So we write square root and then blank, which I usually write with a parentheses, and then plus 2. In our blank, we write G of X, which is 4x squared minus 18. So then if I drop that parentheses, this would be 4x squared minus, or that's, yeah, minus 16 overall. Now with this one, it is possible that maybe something could be pulled out and actually reduce. If you look at this, this is a 4 times an x squared minus 4, if you pull a 4 out. When you have two things under a radical that are connected by times, if one of them is a perfect square, it can come outside. So that square root of 4 would be a 2. This does not actually simplify because that is a square and that is a square, but they're separated by a minus. You cannot separate them out and take them outside unless there's a times symbol between them. So we normally just leave that part alone. So that's as simplified as I can get with that one. With G of f of x, we're going to plug so we're going to start off with the G, which is 4 blank squared minus 18, and this time we're plugging f of x into that blank. So f of x is square root of x plus 2. For this scenario, the square root and the square are going to cancel each other out, so you're just left with a 4 and an x plus 2. We will distribute the 4, so that's going to be 4x plus 8 minus 18, and then if we combine like terms, that would be 4x minus 10. So there is part B, all 6 operations performed. Any questions, or do we feel okay with that? And again, this did not ask for domain, so you don't have to worry about the domain of these. If it doesn't ask for it in the directions, you don't need to worry about it. Which part? Which x squared part, Lexi? Okay, so this guy right here was the x part. See, when you do a composition, that x that was in the original becomes a blank. So that blank right there was still being squared. So this stood This right here used to be x squared. What we plugged in for the x was the other function, which was the square root of x plus 2. So notice that x got replaced with this, and we still had it squared. So when you square a square root, it cancels out and you're just left with the x plus 2. So this and this symbol cancel each other out, the 2 and the square root. Does that answer that, or is that okay? Okay. All right, let's move on down. These should go pretty quick. For 10, we're looking for the domain. When you're talking about domain, only certain functions have problems. For example, yes, a square root has a problem. If you have a square root, you have to keep the inside positive or 0 so that it doesn't go imaginary. This is an odd root. Odd roots have no restrictions. So if it's an odd root, your domain is just everything. So the domain of this one is negative infinity to infinity. If that had been a square root, we would have had to set 3x plus 7 greater than or equal to 0, just because that's what we do when we have even roots. So odd roots have no problems, even roots do. Which is a great follow-up question, because then someone asked for B part. So for this, because it's an even root, the part underneath the even root has to stay greater than or equal to 0. So we set x over x minus 5 greater than or equal to 0, and we have to solve this. Unfortunately, in this specific scenario, this goes back to what we were doing in the very first question. This is a fraction with an inequality. So my critical values are 0 and positive 5. 0 came from the top because that's what would make the top 0. Positive 5 comes from the bottom. This one would be closed because the equal to follows with the top part. This is always open. So we have to do a chart. Anytime you have a fraction with x's on top and bottom and an inequality, you have to do the chart method. So here's 0, here's 5. I need a test value for each one. I could use -1, +1, and 6 because those are each on each side of those numbers. This would be closed and open. So that's negative infinity to 0, 0 to 5, and 5 to infinity. My two things I'm plugging into, this should go pretty quick. They're not too bad. That would just be negative. -1 minus 5 is also negative. Two negatives make a positive. 1 would be just positive. 1 minus 5 would be negative. Positive and negative make a negative. 6 is positive, and 6 minus 5 is also positive. Two positives make a positive. Since this is greater than or equal to, we circle the positive cases. So it looks like my domain is negative infinity to 0, unioned with 5 to infinity. Now, before you freak out about this one, this is not usually something we put on the test. Remember, reviews are going to have mixes of easy and hard problems and medium problems. This is just showing you that why we taught you about those inequalities is because sometimes they pop up in a domain. But I would not stress about B. If you can do A and C and D, you should be good. This is kind of increasing the intensity to show you that they do get more complicated. So that's how you do B. You have to do the chart because the whole thing is underneath the radical, the denominator and the numerator. What's more likely to be a test type question would be something like D. So let's look at that one. So for D, you have two problems. You have a radical that's even on top, so this needs to stay greater than or equal to 0, and you have something that is factorable on the bottom. Remember, neither one of these needs to equal 0. They need to be not 0. We have to factor this trinomial, factors of 24 that make -5. I would go with -8 and +3. So I know that x cannot be 8 because of this factor, if I solve that, and x can also not be -3 because of this factor. So both of those are excluded. We now need to look at the top. The radical has to stay positive. So we set it greater than or equal to 0 and we solve for x. We subtract over the 10. We divide by 2. And you do not need to flip your inequality because you're dividing by a positive. Okay, so here's what I have. I know right now on my number line that I have to be greater than or equal to -5. So that means right now, this is what I'm looking at. The number -3 would be right here, and 8 would be farther along. Both of those caused issues because they're in the denominator. So now all of a sudden you have to create these open circles on those specific numbers. What that means is you now have 3 correct intervals for shaded regions. This would be -5 to -3 parentheses, because that now is an open circle. -3 to 8, because that's in between those. And then 8 to infinity. So that would be my domain for part D. Are we okay with that one? Everybody okay still? I've got a couple people responding. Did I put some of you guys to sleep? Doggone it. Math makes you tired. All right. So as soon as this finishes, it's saving right now. It's trying to upload a save. I'm going to scroll down and look at our next one. Sorry, my computer's getting slow the more ink that it has to save. Come on, save. There we go. All right, so now we can scroll down and look at number 11. I believe there was one question about 11. Part B. Yeah, this is the determining whether it's even or odd. The test for this, you pretty much do the same thing for each test. There's just one extra step when you're testing for odd. Remember, even has y-axis symmetry. That's what we're looking for. And odd has origin symmetry. So here's how the test goes. You want to prove something is even, you want to prove that if you plug in a positive x and a negative x, they end up having the same y. So what we need to do is show that this equals the original. So we take our function, and anywhere we see an x, we plug in a negative x. We then work out the signs. What I mean by that is you say, what would happen if I raise a negative x to the 5th power? Odd powers will make it stay negative, so this ends up being -3x to the 5th. This is also an odd power, so now this is -x to the 3rd. This would be -5x, and this is a +7 still. That does not equal the original function. So notice the original function was all 4 signs were positive. This is no longer all 4 signs are positive. So that means that this fails the even test. To do the odd test, you want to prove that f of x, or excuse me, f of negative x, sorry, equals negative f of x. What this says is if you plug in a negative x, you get a negative y. So what we start out with is the same negative x plugging in that we did before. So we plug it in for all the x's. So essentially it's like you're doing the same test except for the very last step. So you say this is -3x to the 5th, -x to the 3rd, -5x, and +7. The special step that comes in when you're doing odd is at the end we factor out -1. That will then let us look and see if it equals -1 times f of x. So if I pull out a -1, that would make this guy positive. The second one would also be positive. The third one is positive, but the last one goes negative. Because of that negative right there, that does not match the original function. So this is not -1 times f of x. So it's also a fail. So if you plug in a -x for even, it has to equal the original function just once you work it out. If it does not, it's a fail. If you plug in a -1 and test for odd, at the very end you pull out a -1 and what's in the parentheses has to match the original. If it doesn't match exactly, you have a fail as well. So this means this has neither. This function is neither even or odd. So that is how that would work out. Are we okay with that one? And it's been a while since we did that because that was in section, I want to say 3.4. Okay, so let's scroll on down. We're almost done. We're looking at number 12 next. So for number 12, we are doing this difference quotient. That's the formula we're supposed to be working out. The way that I do this is I actually work out this part first, and then I work out this, and then I just write it all as my numerator. So I'm going to do f of a plus h just as an evaluation, and then I'm going to do negative f of a. I'm going to go ahead and take care of that negative sign while I work it out. So f of a plus h means that you take your x and you turn it into this binomial, a plus h. You then have to FOIL that out because it's squared. When there's a number out front, you want to FOIL first, then distribute the 5. So this would be a squared plus ah plus ah plus h squared. And we have our -1. And so this would be 5a squared plus 5ah plus 5ah plus 5h squared, and we still have a -1. So this whole thing, this a plus h part that comes from the top, ends up being 5a squared plus 10ah, because I had two like terms, plus 5h squared and a -1. So that's just that top first evaluation. For the second evaluation, we're doing negative f of a. So what that means is you take -1 and you multiply it by the function with an a instead of x. So this one's a lot easier. So that instead of writing x, I wrote the letter a by itself, and then I have a -1 that I need to distribute. So notice this is taking care of our subtraction step for us. So what we do is we take this part and we write them in our actual fraction up here. So let me get myself a little bit more room. So I write those two things on top. So I write the first one, and then I write this one. I don't have to worry about changing signs because I already did it. And we write that all over the letter H. So then if you've done this correctly, some things should cancel out. 5a squared and negative 5a squared, and -1 and +1. Essentially the only thing that should be left on top is things with the letter H. Notice that if we break this up, the H's can reduce out. This would just be 10a, and only one of the H's can reduce here, so that'd be 5h. And those are not like terms, so that's as far as we can go. So this is 10a plus 5h. Are we okay with that one? All right, so it looks like most of you are saying you're okay. So we're going to move down to number 13 in just a second, which is the piecewise function. My poor computer. It's still trying to save that last problem. All right, come on computer, you can do it. Don't give up. All right, it looks like it finally saved it. Okay, so let's look at 13. This is sketching. Remember, a piecewise function, which means a function that has different directions based on where your x's are. I need to, trying to make this go down. It's not wanting to go down. I need more space. Come on, computer. All right, give me a second. My computer's not liking the enter button at the moment. I'm going to close this and reopen it. So just give me a second. Sometimes this thing gets locked up the more ink gets on the page. And now it won't let me do anything. We shall kill Word then. End task. Haha. All right, let me reopen it. The joy of technical difficulties. Okay, so we were on 13. There we go. So let me see if I can now add some spaces. I should be able to. Yep. All right, so when you're doing a piecewise function, you have to do this in parts. You essentially break this up into different equations for every line. So I would start with y equals x plus 3, and that's when x is less than or equal to negative 2. My next table will be y equals x to the third. That's when x is between negative 2 and 2. And then y equals 4 minus x when x is greater than 2. Okay, so you make a table for each of these, and then we'll graph them on one big graph that we're going to set up over here at the end. And those are not equally spaced, but we will just do the best we can. Now, what I saw a lot of people miss on the quiz on the piecewise function was that they did not start with this number in your table. Even if this doesn't have an equal to here, you still have to start with that endpoint. The equal to just tells you if the endpoint is opened or closed. So because this has an equal to, that's going to be closed at negative 2. We also need to pick x's that are smaller than negative 2 because of the less than. Then we plug them into this equation up here. So this is negative 2 plus 3, negative 3 plus 3, and negative 4 plus 3. That would be 1, 0, and negative 1. So I usually go ahead and plot that graph. So negative 2, positive 1, closed circle. And then negative 3, 0, it doesn't want to make it closed. Closed circle, not open. Negative 3, 0, which would be right here. And then negative 4, negative 1. And because this keeps going back forever, I would keep that direction going for that line. Because this says less than or equal to negative 2, which means it keeps going backwards forever. For my second one, I'm going to do this one in a different color. We'll do it in red. We're plugging into x cubed, and we have to go from negative 2 to 2. So negative 2, negative 1, 0, 1, 2. You don't have to do all of those points, but anytime I have a starting and an ending, I do all the integers in between. Both of these endings would be open because there's no equal to bars. So then this is negative 2 cubed, because we're doing x cubed this time, -1 cubed, 0 cubed, 1 cubed, and 2 cubed. When you cube a -2, you get -8. Cubing -1 would be -1. Cubing 0 is 0. Cubing +1 is 1. And cubing +2 is +8. So we have to go -2 and then down 1, 2, 3, 4, 5, 6, 7, 8, open circle, -1, 1, 0, 0, 1, 1, and then 2 up 1, 2, 3, 4, 5, 6, 7, 8. Now notice this is a cubed function, so notice I have that cubed shape to it. That's not a good drawing, but this has that cubed little slant in the middle where your parabola looks like it got split upside down on one side. And then our last one is this piece right here, 4 minus x. So then we pick things that are 2 or bigger, but remember it's going to be open because 2 is not equal to. So 2, 3, 4. Plug them in, 4 minus 2, 4 minus 3, 4 minus 4. And that's not wanting to stay. There we go. So that would be 0 for that guy, 1, and 2. So 2, 2 is going to be open, 3, 1, and then 4, 0. And again, this one goes forever bigger, so even though that's going down, that's what's happening as the x's get bigger, the y's are going down. So that would be our piecewise function. And I know my red's a little bit overlapping here, but if you pass the vertical, you should be able to pass the vertical line test if you put this on an actual gridded graph. So remember, each vertical line would only pass through one section of the graph at a time. And if it crosses through 2 endpoints, they either have to both be open or just one of them has to be open. They cannot both be closed. So this is okay, and this one's okay because at least one of them is open. Is that okay for everybody? It's not the best drawing in the world, but it's what I could do without a graph. Okay, so we are moving on to 14, so we only have a couple questions left before the end. So for 14a, we're supposed to put this into parentheses x minus h squared plus k format. That's what our directions say. Anytime you're trying to put something into this format, you need to complete the square. And this is the level, I mean, I think you should still be able to do one with a number in front, but we would usually not on a test give you a negative number in front, but you could still have a 2 in front. So you do still need to know how to do part B as well. So for this, the first step is to separate the x terms from the non-x term. And what we do is we create a space for each of those. We're going to complete the square on this first part, and then we're going to use the ability to add and subtract the same thing to both sides to counter that so that we really added nothing. The whole point of doing that is so that this part will factor nicely. So when you're completing the square, you have to take half of the middle term and square it. Now we don't turn that into a decimal. We just say that that's an odd number and we square top and bottom. So that would be 25 over 4. So I'm going to add a 25 over 4 here. Notice I didn't have to worry about this because there was a 1 in front. To counter that, you would subtract 25 over 4. So then the next line down, you would factor this trinomial right here, the first 3 terms. The nice thing about this is it always factors using the sign and the number in the middle right here. So this would be x plus 5/2 squared. This will have to get a common denominator to be able to get. So that would be -8 over 1 minus 25 over 4. Multiply both top and bottom by 4. That's -32 over 4 minus 25 over 4, which is -57 over 4. So that would be my vertex form. And then says I need to state the vertex. So that would be opposite of the sign in here and exactly the sign there. So -5/2 and then negative 57 over 4. So this one, even though it didn't have a 1 in front, or it didn't have a number other than 1 in front that we had to pull out, the middle being odd made it a little bit arithmetic challenging. Is that one okay? All right, we have almost reached the end. We have 2 more question sets. 15 requires us to graph and then describe the transformation. On the test, we split that up into 2 separate questions. So 15 will not ask you to actually write the description. That part will be taken care of in something like number 16. So it doesn't hurt to write the descriptions as well, but I'm going to focus mainly on the graphing part for 15, and then on 16 we'll write the descriptions out because that's more like what it's going to be on the exam for you guys. So let's look at C. So we had these transformations that we learned about, and remember, if you are struggling with this, there is always the table of values. If you do a bunch of numbers for X into a table of values, you can still usually get a pretty accurate graph. The problem is you have to know what the shape of the graph looks like, because then at least you know if your graph looks correct. This has a square root in it. The square root, just square root of X, as a graph looks like this. So this is called the parent. And remember, there were 5 of them that I told you to learn from section 3.5. X squared, X cubed, square root of X, cubed root of X, and absolute value of X. And there was a picture of each parent there. The square root of X starts at 0, 0 because the square root of 0 is 0. It also has the ordered pairs. Square root of 1 is 1. And then the next perfect square on the number line is 4. Square root of 4 is 2. So these are the first 3 points on the square root function. 0, 0, 1, 1, and 4, 2. So that's what our shape should look like, sort of a parabola half on its side. When we have a negative either in front or inside of the parent, that means some kind of reflection has happened. Notice on B part, the negative is out front. That means that it reflects over the x-axis. If the negative is inside with the x, it's going to reflect over the y-axis. If there was a plus or minus inside, so look back at part A and part B, if there's a plus or minus inside the parent function, that means, remember, you're shifting either right or left. So on this one, it's opposite of what we see. So this would be a right 4 and this would be a left 2. This one doesn't have a plus or minus underneath the radical. So when it's outside of the function part, so outside of the parent, it's either going to be up or down. It's a vertical shift. Vertical shifts, you do exactly what you see. So this would be a shift down 1. So what we're going to do is we're going to take each point in this graph right here and we're going to do those things to it. You always do the order of operations as what happened closest to X first and then what happens after. So we should be doing the negative X since it's closest to X first, then the minus 1 since it's outside of the parent. So I'm going to take the point 0, 0, so I'm just going to put my cursor here. I'm going to make myself some lines. Try to make this a little bit nicer this time. Okay, the first thing I'm supposed to do with the point 0, 0 is reflect it over the y-axis. It's already on the y-axis, so you can't reflect it. So that one stays, part 1 just stays where it's at. But then it needs to be shifted down 1. So this is the new home of 0, 0. Okay? It was reflected over the y-axis, but since it was on the y-axis, it stayed where it was, and then it went down 1. Put the point 1, 1 with your cursor or your pencil. 1, 1 needs to be reflected over the y-axis, so now it's over here at negative 1, 1. So see, it's where I'm circling, if you can see that. It's easier with the highlighter. So now it's over here, and then I need to shift it down 1, so now it's on the x-axis. And then my last point was 4, 2, so I locate that. I need to reflect it across the y-axis. That means it goes all the way over here to negative 4, 2. So its x is now negative. So now I went from 4, 2 over here to negative 4, 2. So that's where I'm at right now. And then shifting it down 1 would put it at a height of 1. So notice this parabola is headed in the opposite direction, or this half parabola. So since it got reflected over the y-axis, it's going like this now. It's going up a hill to the left instead of up a hill to the right. And it's also been shifted down 1 from the origin. So that is how that should be transformed. So before I move on to D, is that one okay? Seeing a few people are saying okay. All right, we also need to look at part D, which is an absolute value. I don't know why my computer's locked again. There we go. So let's make some space for D part. Move it down. So the first thing you'd have to do is realize that because this has an absolute value symbol in it, it has a different shape than the one we were just doing. Absolute value of x has a V shape. And you can find it by just plugging in -1, 0, and 1. -1 with an absolute value would be +1. So -1, +1. Absolute value of 0 is 0. Absolute value of 1 is 1. So because it's an absolute value, I always remember absolute value, V shape. So then this is our parent that we're looking at. This is our shape. When you have a number in front, this is either going to be a stretch or compression in the y direction. So if the number in front, so this A number, whatever this is greater than 1, you stretch in the y direction. If it is between 0 and 1, which is what we have, you compress in the y direction. What that really means is your y's are going to shrink compared to where they are now. The height is going to get smaller point by point. So what I think of this is that we're taking each y value, because it's affecting y since it's outside of the parent, and timesing it by 1/5. So for example, if you take those 3 points, -1, 1, 0, 0, and 1, 1. You're going to transform them. You're not changing any x's because, like I said, if it happens outside of the parent, it's affecting y. You're going to transform them by multiplying each of them by 1/5. Actually, let me write that in the other order. 1/5 times 0, just like the first one. And then the last one would be 1, 1/5 times 1. So essentially we're compressing or shrinking those y values down. So this ends up being -1, 1/5, 0, 0, because 1/5 times 0 is still 0, and 1, 1/5. So when we plot our final answer, notice that that's going to make this graph a lot more compressed. So here's 0, 0. 1, 1/5 is very tiny, and so is -1, 1/5. So notice this V is growing really slowly. It's really wide. That was not a good V. So here's -1, 1/5, and then that's growing really slowly. So notice this normal shape has been squished down vertically. Are we okay on that one? And again, if you're freaking out about these or if they make you scared, you can still do this with a table of values. If it asks for a description, obviously you'd still have to know how to write the description of is this been compressed or stretched, but a table of values is still okay. Okay, Abiyadun, what is your question on this one? You can put your mic on if you need to.
Okay, like how are you getting like the parent shape, the parent graph? How are you getting the -1, 1, and 1, 1, 0, 0,
Well,
like the one you did previously also?
okay, so when we taught this in class, I said you mainly just memorize these because you do them so many times with the homework, but you can always do it by a table of values. So if I plug in -1, what's the absolute value of -1?
Yeah.
It'd be 1. If you plug in 0, the absolute value of 0 is 0, and absolute value of 1 is 1. So you can get the parent by a table as well to get your 3 points.
So do you come up with the one -1, 0, 1? Do you
I,
come up with it, or where do
I
you get that from?
I use those for the ones that are squared, cubed, and an absolute value because those are really easy to plug in. If you're dealing with a
Okay.
square root, you only want to plug in perfect squares. So notice when I did my square root up here,
Uh-huh.
I picked 4. Do you see how I picked 4 as a point for x?
Yes. Uh-huh.
Because I know that 4 is a perfect square. So notice I picked 0, 1, and 4 because all of these were perfect squares, which made them easy to evaluate. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So you can pick
Oh,
any x's you want, but usually 0 has to be in the group, and you want to make sure you pick things that are going to evaluate. So you can't like put anything in that's going to give you an imaginary number.
okay.
So if it's a cubed root, I would be careful about doing -1, 0, and 1 because that makes it look like a straight line. For the cubed root, I always use -8, 0, and 8 because remember, -8 and 8 are also perfect cubes. So when I'm dealing with the roots, I just try to make sure I'm careful about what numbers I pick in. But if I'm doing the other 3 parents, -1, 0, and 1 are the easiest things to plug in.
Okay.
So just as long as you know those parent shapes, you can always get the points you need by doing a table. Okay,
Okay.
that's a really good question. I'm glad you asked that. Um, so let's do 16b and then we will be done with you guys' list. Woohoo! It says if you have a graph for f of x, explain, so we're going to be writing a sentence, so we're not graphing, what the transformation would be necessary to graph it. So we're not actually graphing it, we're just explaining it. So notice we don't even care what h and f are. We don't care what this parent is. We just want to know if there's a +1 inside of a function's parent, what does that mean? If it happens inside as a plus or minus a number, that is a horizontal shift. So I'm just labeling this and then I'm going to write a nice sentence. In a horizontal shift, you always do opposite of what you see because it's happening inside the parent. So since that's a +1, we actually think -1. So that means we move to the left 1. Now there are 2 things happening outside of this function. The negative sign and the 1/3. They are actually 2 different types of transformations. If you have a number in front, remember that's either a stretch or a compression. If the number is bigger than 1 out front, that's a stretch. If the number is between 0 and 1, it's a compress. So as long as we don't look at the negative right now, that 1/3 is between 0 and 1. So that means that's a compression in the y direction because anything that happens outside of f happens to y of 1/3. The negative out front means you have a reflection. A negative out front means you reflect over the x-axis. If you have a negative inside, like a part, you reflect over the y-axis. So where the negative is located tells you which one you're reflecting over. So if we put all three of these things together to write a sentence, you have to be careful because on the test, if you don't write these in the correct order, I do have to take off like a half of a point. When you do this, you need to write them in the order that what is happening closest to x. So the first thing that's happening close to x is the left one. Then the 1/3 would be next, and finally the -1 out front, the negative sign essentially. So that means this should be listed as 1 and then 2 and then 3. That would go for graphing as well. We would do them in that order for graphing, but definitely when we write the description. So this says that function h, because that's the outside that we're looking at, I'm just trying to write a complete sentence. So function h of x is f of x shifted left 1, compressed in the y direction by 1/3 and reflected over the x-axis. Now if your wording is not the same as mine, that's not the end of the world. The big thing I'm looking for is correct descriptions in the correct order from the order of operations. So if you don't use the words exactly the way I do, if you say it's a y compression of 1/3, that's still the same thing. You're just saying it with different syntax. So make sure you know what the transformation actually means and write it in the order of closest to x, working your way out. If you have a plus or minus something at the end, vertical shifts are always listed last, because that's something you would do after multiplying by whatever's in front. So like if I was listing these for A part, I would talk about this one first, this one second, and then that third. So if you're listing them, you make sure you work from X out. Is that one okay? Okay, I know it was a long session. We grilled this out for an hour and a half, so I hope that I got to all of your topical type questions, the things that were bothering you the most. I hope that you found this beneficial. You're free to go whenever you need to. If you need to stick around and ask me a question, that's fine. I'm going to stop the recording process. So if anybody wants to ask anything based on anything we've done tonight, you're free to, okay? If